Welcome to this Aito UX Design Studio demonstration. My name is Finn Solén and I work as an electronic application engineer for Aito. I assume that you have installed the software already, that you have a demonstration board AitoChip, and that you connect it to 12 volt and the USB cable to the laptop. Press this icon to start the Aito UX Design Studio. And we switch to advanced mode. And in this screen, we first of all program the Arduino as a bridge. COM15 is the only one we have here. Press OK. And down low, here we see operation in progress. We have to do this as a bridge when we have a laptop in order to transfer all the configuration parameters from the laptop via the Arduino into the AitoChip. We see here on the lower part that Arduino bridge discovered on port COM15. We also see that it is an AitoH700 demo version 3.0, and this is the I2C address. We can also see it here. If we don't have any contact, we will have one of these virtual devices. But now we have contact and we have this. The demo configurations are those who are coming with your first software, and this is what we have self-made. It will be empty the first time. Now you can either make a new one, or we take one from here, right-click, duplicate, right-click, rename to whatever. On the right hand side we see the stiffness. The stiffness is actually the parameter telling us how difficult is it for the piezo to move in its mechanical application, depending on the stack setup and on the overlay. Apply to all keys means that this number, the stiffness 85, will be applied to all keys, whatever the actual stiffness is. This means that the AitoChip will make a self-calibration and check what stiffness it can feel and apply that to every key. The overview is just, here it's just text. You can write whatever you want, and we see that we have 3 keys. No buzzer and no general purpose. In channels we can change this to piezo IP or the general purpose outputs, push-pull, open drain. But in our demo setup we have only 3 keys, so we program it like this. I also want to mention that the hardware is also configured as a piezo or non-piezo. So in the demo board, which is actually possible to use 8 channels, there are with resistors enabled or not enabled. We should make sure that we have the same amount of channels configured here as on the hardware. So the hardware have 3 piezos, so we also put here the first 3 piezos. Enable them. Okay, in our demonstration kit we have 3 keys, so let's configure them now. Key number 1. Here we have the sensitivity. The global parameters are the sensitivity and detection area. When we change the sensitivity, it is how hard we have to press to get an event. Now it's a high sensitivity, we don't press so much. Here we go to low sensitivity, and we have to press much. Detection area is how close to the center of the piezo we have to press. In the key 1 press event, we will define what shall happen when we press the key. Let's keep to only haptics for the moment. We see here the response delay. This is how long time it will take before we have the haptics. After that we have press event. We can have several pulses. Well, let's take this small. It's nicer with a short response delay. 2 pulses. We can have a duration per pulse, and we can also put an interval between the pulses. If we now, this is defined as 1 burst. If we now have 2 bursts, we will just copy what we have, and we can also have a burst interval. Let's make this simple. We have 1 burst count, we have 1 pulse, and we have a pulse duration like this. 25 is nice. Pulse interval we don't need, it doesn't matter what you have it to. Now to test this, we need to load it to the device, and you will see under here when I press that we have nothing. Maybe because the sensitivity is too low. Let's do it again. And I press, yeah. Now I can see that it is working fine. So really you have to fine-tune these parameters to make it work good. You see here what's happening on the line, that I pressed the Aito demo version 3.0, the I2C address, and it was pressed for 1 second. If I press it now longer, you see 1.1 second it was pressed. Okay. If you now go further down, we have 2 important parameters. This is the sharpness and the strength. When we have a sharp pulse, it will really feel sharp in your finger, and you will also hear that it is like sharper. Now I press it, and you hear this, and you really feel it in the finger. The strength is actually how big pulse we should do. Actually, how high voltage it will be. So if I have a weak pulse, load the device, yeah, it feels quite weak, and we do it strong, and we have a strong, distinct haptic here. We do the same thing for the release event. Actually, we program exactly in the same way. If you now have several keys and you want to have this also key 2, you just drag it there. If you want to have all the keys the same, you right click and you can do copy and paste to all. Now all the keys have the same behavior. Okay, now we have programmed all the piezo keys. If we go back into File, Arduino, program Arduino's host, we will program the Arduino with all the parameters that we just had done. If you have your own host, not an Arduino, but you just want to have the C code, then you go into here, code output, and the C code will be placed in this directory. If you press yes, now we will go actually to the Arduino application. We don't do that. I would like to show you here the AitoChip user manual. This is the manual where all the details are described. We have how the configuration is done, all the registers, everything is written inside here. I think it's a good idea for you to look into this if you're working with a UX Design Studio. If you need some more information, you can always go to our website www.aitotouch.com or the email info@aitotouch.com. It's also a minus sign between Aito and touch. Okay, thank you very much and goodbye for now.